Hi guys, today we're going to be talking about chromatography, so let's get started. So what is chromatography? Chromatography is simply a separation technique that uses differing physical and chemical properties to separate the components of a mixture. There are several types of chromatography, including but not limited to gas chromatography, liquid chromatography, and column chromatography. And in real life, this technique can be used to track the progress of a reaction, to figure out which compounds are present in plant samples, or to identify clues at a crime scene like blood, ink, or drugs. Okay, so let's look at how chromatography works. And to do that, we're going to go over some definitions first. You have the mobile phase, which is the solvent that moves through the column, and then you have the stationary phase, which is the material in the column that absorbs the sample you are separating. Then you have the eluent, which is the fluid that enters the column, and then the eluate, which is the fluid that exits the column after being passed through the column. And this can be collected as a fraction and then used for analysis later on. Essentially, what you're doing is putting the sample into the stationary phase, and then using the eluent to separate the components of the mixture based on their varying affinities for the eluent itself. And now we get to the big question, how? There are a number of properties that can be used for chromatography, but one of the main ones we'll look at today is polarity. Now, if we're going to simplify this chemistry to a very basic level, the main idea is like dissolves like. This just means that polar substances attract polar substances, and nonpolar attracts nonpolar. For chromatography, this means that if you're using a polar solvent, then the most polar component will come out of the column first, or it will move the furthest on the paper in paper chromatography. Alrighty, that was a lot of information. So we're going to do an experiment, and hopefully it will make everything else make a lot more sense. This is the paper chromatography lab, and basically what we're doing is separating the components of black marker ink. The setup is rather simple. We put a black dot on chromatography paper, and then place that in a salt solution in a glass. You can even pause the video here and try it at home using the procedure I wrote down if you're interested. Let's see how it turned out. So this is a time lapse of the paper chromatography. Again, this is a fun experiment that you can try at home without having to buy any materials. As you can see, the salt solution moves up the chromatography paper by capillary action, and as it passes the black dot, it carries the ink with it and separates it in the process. The black ink separates into blue and red primarily. The blue travels the fastest and the farthest, while the red, which shows up as brown with pink traces, though it does travel a little, takes a lot longer to do so and doesn't travel as far. Here's our data. The baseline is marked at 0 centimeters, and we base the rest of the measurements off of our baseline. If you notice, the baseline is not the lowest point of black ink, and that's because the ink, or some of it at least, leaked down into the solvent instead of moving up. The red band, which is sort of brown and pink, is at 2.91 centimeters, and the blue band is 5.8 centimeters. For the bands, you want to measure to the center of the band, not the top or the bottom of the band. This just keeps the data more consistent. So why does the blue travel farther than the red? The simple answer is that the blue dye has a greater affinity for the solvent, the salt water, than the red dye. We can explain this by looking at the structures of the dyes themselves. The blue has 3 of these charged sulfide ion regions, which act as binding sites for the dissolved sodium ions in the salt solution, which bind to these sites because of their opposite charge and pull the dye up the paper with the solution. Because the blue has 3 binding sites and the red only has 2, the red doesn't bind as well. As a result, the red doesn't travel as far as the blue, and the 2 components of the black ink mixture are separated. A common calculation performed with chromatography is the RF value, which just stands for retention factor and is a quantitative way to look at chromatography. A lower RF value indicates that the substance is more attracted to the stationary phase, and a higher RF value indicates that it is more attracted to the mobile phase. The equation is distance traveled by component divided by distance traveled by solvent front. Using this equation and our data, we can calculate that the blue RF value was 0.767 and the red was 0.379, showing quantitatively that the blue dye was more attracted to the salt solution than the red. Well, that's it for today, guys. Thanks for watching, and I hope you learned something about chromatography.